Hello, so continuing on this contest 162, the last problem, which is a hard problem 1255 or 1255, maximum score words formed by letters. So the problem says we get a list of words and list of single letters that we may have, they may be repeating, and a score for each character. So each character in this letters array has a score. And we want to return the maximum score of any valid set of words, right? Formed by using the letters. And so you notice here that each word cannot be used more than once, only once, right? Or 0 times, right? So it's not possible to use all, if it is not necessary to use all characters of letters, but we should use each letter only once. And the scores of letters is for A, it's in position 0 of score array, for B, position 1, and you get the idea. We have 26 letters because these are all lowercase letters, and these are the values in score array are the scores of each letters. And so you can see here we have this words array, and we have these letters of these letters that we are allowed to use, and the goal is to return the maximum score that we can get by taking some of these words, or maybe all of them, if we can, because we are constrained by the fact that we can't take any more characters than what's in letters, right? So the problem gives us the score. And so, for example, in this example here, we can take with these letters we can form dad and good and get the score of 23, or we can form dad and dog and get the score of 21. The maximum one is dad and good. We can't take dog along with good because we have only one instance of J and only 2 instances of O. So if we use them for good, we can't use the one for dog, right? So you get the idea. And the similar thing for the rest of the examples. One thing you could notice though in the constraint is that the number of words is just at most 14 words. And the length of each word is at most 15 letters, and the number of letters that we can have is at most 100. So you could see here that the bounds are very small, so potentially we can find a solution that is not too complicated. Okay, so let's see how we can solve this. This problem. So the first thing to notice here is that the problem is asking for a maximum score, right? So probably something with either dynamic programming or backtracking, or maybe just exploring all the choices, right? So the first thing that comes to mind is we have some kind of a state here, right? So we have some kind of a state that depends on, like, which word are we considering, right? Which word are we considering? So that we can check if it's possible to take it or not. And that we can keep track of that by having position I, right? In the list of words, right? The other state is that what are the letters that we can still use, because when we take a word, we shouldn't use the letters that word used one more time, right? And so we kind of have something also else, which is the remaining letters. That can be used. One other thing that is kind of the goal that we want to return is, maybe let's call it goal, just to make this a little bit more. We need the score, right? We need the score. Score so far, right? So one thing to think about here is that at each position I, we have 2 choices, right? So let's write that down. So at each position I, we have 2 choices for a word. And those two choices are the following. We can either take the word, if possible. Taking the word basically means adding it to score, adding its score to the value, adding its score to the overall score, so adding it to score. And then removing the words in the letter the letters used in that word from the overall letters. Removing the letters used from letters, right? Or the other choice that we have is skip the word. At that point, we don't need to update any state. And this portion here is just updating the state that I defined here, right? And also, one thing we need to update is also update the goal. So that's just adding to the score. So updating the state plus score. All right. And so we decide one of these choices and then keep exploring the choices that result from this, and explore the choices that result from this. This one has the advantage that we haven't taken some letters from the overall letters that we have, and so maybe we can add more words as a result of that. Or maybe taking the word was the better choice. We don't know. We can know in advance. So explore both cases, and then once we get back to the top level of the recursion, we take the max of both cases, right? So that's the main idea of this solution. Now, a couple of things that we will need to figure out in order to do this. One is this removing the letters used in words. How can we achieve that? Adding the score would be easy. We have the score array, so we just need to figure out the letter position and add to the score, and do that for every letter in the word, right? That should be straightforward. Now, the problem is, how can we remove the letters? So in Python, you could, for example, if we were to use sets, which we can't here because we can have duplicate letters, but if we were to use sets, we could just have the set of the letters minus the set of letters in the word that we are considering, and this will give us the remaining letters. But we can't use that in this case here because we have duplicate letters, as the problem said. We may have, like, let's say the first example, we had letters O and O 2 times, so we can't use that. But we can use something else in Python, at least that is very similar, which is counter. So counter has this thing where you could do the same thing for sets, but we could do counters of letters minus counters of words, and that would give us of the word letters, and this would give us the remaining letters. So basically, instead of representing the letters remaining by just the array letters, we represent them by this. And basically what counters does is, if you have, let's say, A, B, C 2 times, D, we would have A saying it occurred 1 time, B occurred 1 time, so it would be a mapping from the character to its number of occurrences. C occurred 2 times, D occurred 1 time. And if we have a word, let's say so this would be the overall letters counter. And if we have, let's say, a word that is, I don't know, let's say BC, for example, then doing this formula here, what we will get is the following. We would get, so this here, if we do the counter for word, it would be equal to B occurred 1 time and C occurred 1 time, right? So doing the subtraction of the letters minus the word, that would give us, now A occurred still 1 time because it's not in word. B, now it's 0 time because minus, right? So, and then C, 2 minus 1, C is 1, and D is 1. And so this is what we will pass to the next state, as I said here, by applying taking the word choice. And now you could see here that we removed the letters that were used in Word, so that they don't get used again in the next choice, right? So now we solved that portion. And so let's just write the skeleton of the code here and see how we put everything together. So I would need a helper function that just recurs, that I would call at the end. So I would need a helper function, let's call it helper, that has first the position of the element, because that's what I want here, the position of the word that I'm considering. So it will basically contain the state. So the position of the word that I'm considering, the remaining letters, and the score so far, right? So, because that's what I want to return. And to call that function and return the result at the end, I will just call helper with, so this is what we want to return at the end. Maybe let me just write it down here somewhere, really down, so that we don't. So it would be something like, let's say, return a helper. So we will start out with the first position, and the remaining would be, as we said, the counter for all the letters. So that's the start, and then the score so far, we start out with 0, right? And now let's do this. So when do we stop? So first the stop condition, because this would be recursing, so we would need the base case, right? So if we no longer have any remaining letters to use, or if we reach the end of the words, there is no more words to consider, right? In that case, we could just return the score as the result and be done. Return the solution, basically. Now, after that, we need to do the two choices that we have. So we have the first choice, which would be, so our first choice here is skip word, right? So that's this choice here. So that would be, so I'm going to put the result of that in res here, and so it would be calling the helper function on the next state, but remaining variable or remaining content remains intact because we are not using any word here, so we just pass it along. And the score doesn't change because we didn't take the word, so we pass it as it is. And we see if the next state will give us a better result. And then the other choice is to take the word, right? So the second choice is take the word. And as we said, taking the word means adding it to the score, removing the letters used in the word. So in order to be able to remove the letters that we used in the word, we need to have the counter for the word. So let's just call it CW. That's not a really good name, but so this would be just the counter for the word, just so that I could do what I said here, right? And so to be able to remove the the letters used in word at position I from the overall letters, so that I can remove them and go to the next state, right? And so I have that now, and so I need to check if I can even take them, because let's say letters doesn't contain enough. Let's say we had here maybe G, right? And we would have here G equal to 1. So at that point, the problem here is I can't, because G minus 1, right? And the way to solve that is with this counter, if basically the word there is one here that isn't here, you would get it back as a result. You would get the result of this one would be, basically the result will be empty. I will show that next in the console, but that's what we get. So here we would need to check that, so if it's possible. So this basically checks if it's possible to take the word, which we can do that by saying if the counter, if the length of the count of CW minus the remaining. So this here basically taking the not this, sorry, I made a mistake explaining this here. So basically what can happen is that if we do the counter of the word minus the counter of the letters, if this gives us an empty list, this basically means that there are letters in word that are not in letters. So basically means word contains a letter that is not in letters, basically, which means that we can't take the word, right? And so at this point, if this is equal to 0, we can't take the word, sorry, yeah, I messed this up. So what I meant is actually when this subtracting the values from here gives us some remaining values, let's say in this case j with value 1, that means there was a letter that isn't in this one. If it gives us an empty list, that means that all the letters here were here, because if you subtract, let's say 5 from 5 and get 0, that means all 5 are here, right? If you have 6 minus 5 and get 1, so not that the result is not 0, that means there is a 1 here that wasn't here, right? That's kind of the analogy that you should think about with this one. So if the length is 0, that means all the letters in word are in the remaining letters, so we can take the word. And so taking the word means considering it, and since we want to take the max of both, of the skip and the take, we want to do the max with res and with this recursion step where we need to go to the next word, right? And then we need to do what we said here in the choice, which is removing the letters. And removing the letters, as I said, is just counter letters minus the counter of the words. And so that would be just the remaining minus CW, right? And then we will need to add it to the score. So that would mean score so far plus just taking the sum of mapping. I'm going to define a function that get me a score of letters from the score array. It's very simple. So for now, don't worry about it. It just gets us the score of a letter. And we will map that to the word that we are considering and get the sum of those. This is the overall score of a word. And at the end, we could just return that result. And maybe, okay, let me just make this a little bit more clear. So here, at the end, we return result at the end of the helper function. And in the main function that Leetcode provides, we will initialize the call with 0 for the first word, and the remaining, and then the remaining starts out as the counter for letters, and the score so far starts out as 0, and that's pretty much it. So the main idea is base case, 2 choices, explore both, skip and take, use counter to be able to remove from the remaining letters the letters that were in word, and use it also to check if taking the word is possible, because if the word contains a letter that is not in letters or not in the remaining letters, then we can't take the word, so skip. But if we can, then consider taking it and check if it's give us a better answer and return the result. So let's code this up in Leetcode and see if it passes the test cases. Okay, so let's now code it up and see if it passes the test cases. Okay, so the first thing we need to do is define the helper function that we will use, which would be like this. So that would be, we said we need to pass the state, which would be I, and then the remaining letters, and then the score so far, right? And we will need to say, okay, if we don't have any remaining, this is the base case, or we reach the end of the list of the words. At that point, we just return the solution, which is just score so far. And then we do the two choices, where the first one is skip the word. And then the second choice would be take. And then skip would be just initializing the result. Possible result would be go to the next word, keep remaining as it is, since we haven't taken any word, and so far like this. Take means we need to check first if we can take. So take words I if possible, right? And then to check if it's possible, we need the counter for the current words, right? The current word, which is words I. And then we need to check if it's possible by just checking the length of the difference. So between the counter for the word and remaining equal to 0. And this in Python is just not doing this. That's the same thing. Checking the length is equal to 0. Basically checking that it's empty is basically checking that it's not empty. So what I was going for is checking that the difference is equal to 0, the length is equal to 0, which is in Python, this is the same as if not CW minus remaining. So that's what I will be using instead, but it's the same thing. So and then take the max of the two. So this one, the previous one is skipping the word, and this one, which is taking the word. So going to the next step and taking the word, we need to subtract the letters that we use in this word. And then for the score, we need to update it to add the score for the current word, the word that we are taking, which we can get by just doing map letter score and that would be mapping that to words I to get the score for the word. And at the end, we can return the result, and we need to do the initial call, which starts out from the first word with the entire set of letters, and we start out with 0 score, and we need to return that. Now I just need to define this function called letter score that just gives me a score for the letter using the score array that we have there. And so to do that, I'm just going to return score and get the index by just doing this. So why is that again? Let me just show you in the console here. So essentially, if I do ord C for the character C minus ord I would get the index if we start counting from A as 0, and then B as 1, and then C would be 2. D would be 3 because 0, 1, 2, 3. The value, the index after C is 3, and that's for C is D is directly after C, right? So this is the indexing we are using. So you can see for Z, it would be 25. We have from 0 to 25, and so we could just use that index because that's what the problem says. It says that the value at I is in the so the value for A is at score 0, the value for B is at score 1, and so that's why, and the value for C is at score 2. So for value for B is at score index 1, and that's why we have here 1, right? And so that's why this one would work. The other thing I want to show you is for the counter, how does it work? Why does this difference here work? So if I take the letters, so let me take, for example, letters as this, right? So it's the same as this example here. And let's just say word equal to good, which is one of the words we have. So the counter for letters is, letters actually. So if for each word, for each letter, how many times it occurs in letters. So you can see D occurs 3 times, C 1 time, G 1 time, O 2 times, and you get the idea. Each character, how many times it occurs. Now for the word good, it occurs O 2 times, G 1 times, and D 1 time. So let's just say, counter of letters minus, let me show you first that if we can take the word good, this length here, this would say that it's valid. So counter for good minus counter for letters, let's see what that would give us. So that gives us an empty, right? Because all good is in letters, all of them, right? But let me take a word that is not in letters. So let's take some letters that are not in the letters array. So let's say XWZ, right? So you can see here, counter is not empty. So whenever the difference is empty, that means that the entire word can be constructed from the letters here. If it's not empty, that means there are some letters that cannot be constructed. And to show you really that, let me just, instead of doing good, do good with 3 O's. So there is one extra O that can be satisfied with the letters. And so you can see there is 1 O remaining. So whenever the length is not 0, that means that it's not valid. We can't take the word. And so the second thing is this not here. So let me show you that if I do not for an empty list, that's true. So we would enter if it's empty. But if I do not for a list with 1 element, it would say false, right? Because the length is not 0. Now let's go to this remaining part here. So if I take the counter for letters, right, like this, letters, and then minus counter for good. So first counter to letters has all of these, right? So if I take counter for letters minus counter for good, you could see G is no longer here because it's been used by this word. The 2 O's are no longer here because now they are 0 and they are taken by this word. And then D, which was 3 here, became 2 because one of them was removed. So you get the idea. It removes the extra letters that we are using, that we used in Word. And so yeah, let's submit this and see if it passes. So first we need to import the from collections, we need to import counter. Okay, so it passes the test cases, cool. So we can modify this slightly if we don't want to use counter. Let me just show that for a quick minute. So instead of using counter here, what I can do is just create a function here that get me the count of letters. So a similar thing to the count, that whenever it's given any list of characters, let's say a string or a list of characters like we have in the array of letters, it will just create an array. Since we know we have only lowercase letter, we'll create an array of range 26. And from there, we would just go through every character in the list or of the characters, which can be a string, right? And for the counter there, we would say, okay, counter for C. And in order to get the index, we'll do the same trick we did for the letter score. So that would be order of C minus order of A. And that would be increased by 1, right? Because it occurred 1 time here, right? And then at the end, we can return the entire counter. And now what we can do here is instead of using this count letter here, what I can do is I can use the function that I just created, which would be get count letters. Let's call them letters. and then I could just use that for letters to give me the count array, right? And that way, with that, I could use the same thing here for this word, and I can't do this minus here, that won't work, right? So I need to define a function called subtract that will subtract the count from 1. So we'll say from 1 count, subtract another count, which this, and both have this format of this array. And so to do that, I'm going to just go through every letter, right, in these 26 characters, and I will just compare. If in the first one it's less than the second one, that means that what I'm going to return is basically two things. I'm going to return first returns a pair boolean, which represents the whether count 2 can be is included in count 1, basically. So it does kind of the two things that we did earlier, this one and this one. And the second one would be a counter of the remaining of count 1 after removing count 2 occurrences, right? So that's what I'll be doing here in this function. And so I would have, so basically it's doing just the subtraction, and at the same time it can tell me if it returns true, that means that I can take the word, and if it returns false, that means I can't. And so here I would return count 1. It doesn't matter what I return because the value is false, right? Now otherwise I'm going to subtract from I, right, count I, I'm going to subtract the count at position I for count 2 for the second counter, and at the end I can return true because I didn't find any case where the bigger one that I want is less, right? And then I will return count 1 at the end, right? And so that would allow me here to say just like this. So I would have is valid or can be taken, and I would have the remaining letters, right? And that would be just doing subtract for the remaining with the word, right? The word counter, and then here I would take only if it can be taken, right? And here I would pass the remaining letters, right? There is just one thing, is that if I pass remaining here, it would be modified, right? It would be modified by this, because by this -1, and then the problem is that on the next recursion, I won't like go back and undo my choice, which I should do, and that would affect the next state. So to avoid that, I'm just going to pass a copy of this remaining here instead. And that's pretty much it. So let's run this. So it's almost the same, except we are doing manually the counting instead of relying on counter. So we can just delete this counter here. Okay, I'm gonna submit. Okay, so that also passes. There is another way to solve this problem. Since the boundaries are like the bounds and the constraint are very small, we could just generate all the combinations, the different combinations of the words, and just once we generate them, we could just check each combination and see if all the words in it can be satisfied with the letters. If they can, then get the score and see if it's the maximum we have found. If it is, update the max. If it's not, proceed with the next combination until we process all the possible combinations. Yeah, so that's it. And so yeah, that's it for this problem, I think, pretty much. Thanks for watching, and see you next time. Bye.